Good afternoon, dear colleagues. We bring to your attention a report of the materials of the research, the topic of which is presented on the slide. Speaker is Anastasia Sverdlova. On the basis of the analytical review of the state of development of modern methods for diagnosis the state of atmospheric air, the purpose is creation of modern measuring models of the air pollution monitoring system capable of forming large data areas and solving a number of modern methodological problems of the monitoring system. Atmospheric air monitoring is an integral part of the state environmental monitoring system, which is carried out in order to obtain, collect, process, store, and analyze information of the state of atmospheric air and develop scientifically based recommendations for making decisions in the field of atmospheric air protection. In Ukraine, there were 162 posts in 53 cities. In general, the quality of atmospheric air is determined by 33 indicators according to the approved list for each of the 53 cities of Ukraine. The development of environmental monitoring system in Ukraine in recent years have led to the development in large industrial regions of networks of monitoring posts for the state of atmospheric air using automated monitoring posts. This research is devoted to the development of hardware for measuring models of the atmospheric air pollution monitoring system, which will allow obtain up-to-date information on the level of air pollution using modern microprocessor technology. The approach to building a structure of the technical diagnosis system for smart grid technology allows to diagnose individual levels. It should be noted that sensors are used at levels first and second, then we deal exclusively with information signals. The diagnosis system is implemented in the form of a distributed modular complex, the structural scheme of which is presented on the slide. Is a microcontroller a microcircuit of the STM32F10X family was chosen, which provides the best 32-bit efficiency in the class of microcontrollers. The microcontroller has a high-performance RISC core with frequency of 72 MHz, fast memory, extended input-output ranges, and peripherals connected to APB buses. The MCU is equipped with a 20-bit AD converter, a timer, standard and advanced communication interfaces up to two I2C and SPI, 3 USART, USB and CAN. Power saving mode allows to use it in low power devices. The HC20 module was selected as a transmitter for peer-slave modules, which is an wireless half-duplex UART module that allows to transmit. At the same time, the transmission distance can reach 1000 meters in the open area at a data speed of 5000 bps. The role of the master is played by the SIM 800C transmitter module. This is a model of full-featured quad-band GSM GPRS model from Simcom. Um, in this slide, we can see the printed circuit board in Altium designed CAD, the drawings used to design the VM keys, and the layout of the PCB to check the compliance of the manufactured printed circuit board with Gerber files. Sensor of various physical quantities can be included in the air quality monitoring system. Depending on needs, up to 15 analog sensors and 2056 digital sensor via the one-wire bus, and up to 127 via I2C can be connected to the base model, including particulated sensor, meteorological sensor, sensor for monitoring the concentration of the following substance: formaldehyde, carbon monoxide, carbon dioxide, nitrogen dioxide, ozone, etc. In this slide we can see the wiring boards of the measurement model, 3D model in Artemchuk Designer CAD and manufactured at the GLC PCB factory. A working prototype of the measurement model as an element of an air pollution monitoring system. The table shows the parameter and characteristics of the sensor. Thanks to the provided wide range of sensors, it's possible to expand the range of use of measuring models and the system as a whole. On the slide we can see graphs of PM2.5 dust concentration and radiation background obtained as a result of the operation of the measuring model for 7 days. The location of the measuring model is shown in figure. The measurements were carried out within 1 week. Significant excess of this parameter was not recorded. The measurement range of sensor was 20 minutes, thus a database for more than 500 measurements was formed. Compared to the existing monitoring system, the network built on the development measuring models is able to increase the amount of received data by 18 times. In conclusion, the current state of the existing air pollution monitoring system in Ukraine is shown. The features of air pollution monitoring in different cities of Ukraine are presented. Experimental data were obtained from measuring the concentration of PM2.5 dust and the radiation background of the area where the measurements were made. In comparison with the existing system, the information base of the development model has been increased by 80 times. Thank you for your attention.